In this video, we're going to get a visual understanding of the centripetal acceleration formula. So what I'm going to do is show you a general idea on how we get the magnitude of the centripetal acceleration to equal the object's linear velocity squared divided by the radius. So in this diagram, we have an object that is traveling in a circular path with a radius r. And at each point, the object has a velocity which we will denote as v1, v2, and v3. And in this video, we are going to assume that the magnitudes of these velocity vectors are equal to each other. Or in other words, their speeds are equal to each other. So in order to get this formula, on this circle, we have to replot our velocity vectors and see how these velocity vectors are changing. So let's translate our velocity vectors onto this circle. So we have v1, and notice our velocity vectors are going to represent the radius of this circle. Then we have v2, and then we have v3. Now looking back at our previous circle, our velocity gave us the change in our position over time. So what do you think is going to give us the change in our velocity over time? Well, that's straight from the definition of our acceleration. So we can call this a1, this a2, and this a3. And the analogy I want you guys to see is that as our position vectors are changing direction, what are causing them to move are our velocity vectors. And here in the second circle, you see that as our velocity vectors are moving in the clockwise direction, what are causing them to move are these acceleration vectors. So if we just translated our acceleration vectors back onto our first circle, you will see that our acceleration is pointed inward. And this is why we call it the centripetal acceleration, because they are pointed towards the center. But we just want to talk about the magnitude of the centripetal acceleration. So we're just going to assume that they all have the same magnitude. Now that we got that out of the way, let's try to find a way to determine how long it takes to get from here to here. Well, we can rearrange our speed formula to have that our time is equal to the distance an object has traveled divided by its speed. Well, in this case, our distance is the arc length of the circle. So we can replace our distance with 1/4 2 pi r. So we have that our time is equal to 1/4 times 2 pi r, since it's only 1/4 of the circle we are traveling, all divided by our speed. So this is going to equal the time it takes the object to complete its path. Now the time it takes along this position vector is going to be the same amount of time to complete the velocity path. So again, we have that our time is equal to 1/4, since this is 1/4 of the circle, times 2 pi r. But since the radius is equal to the magnitude of the velocity, we can substitute that and put in speed. And this is all going to be divided by our acceleration, because that is what's nudging our velocity vectors in the circle. Think of it as an analogy to our speed in the previous circle. So to re-emphasize, this equation over here represents this circle, and this equation over here represents this circle. And the time it takes to go from here to here is going to be the same amount of time to go from here to here. So now let's set them equal to each other. So we have 1/4 times 2 pi r divided by our speed is equal to 1/4 times 2 pi, the magnitude of our velocity, which is our speed, all divided by our acceleration. And you can see that we have 1/4 times 2 pi on both sides, so we can cancel them out. And let's move over so we have a little bit more room. And we get that our radius divided by the magnitude of the velocity equals the magnitude of the velocity divided by our acceleration. And we can do some cross multiplication, giving us our acceleration times our radius is equal to the magnitude of the velocity squared. And we can divide each side by our radius so that we can isolate our acceleration to get that our acceleration is equal to the magnitude of our velocity squared divided by our radius. And here we have our centripetal acceleration formula. So in recap, in this video, we got a visual understanding of the centripetal acceleration formula. And that formula states that the magnitude of the centripetal acceleration is equal to the object's speed squared divided by the radius. Thank you for watching this video and hope to see you next time.